All right. Hello, everyone, and welcome to the stream. I hope everybody is doing well tonight. Getting started just a couple minutes late tonight. For some reason, every single account that I had seems to have just logged me out all at once tonight, which was awesome. So I had to log back into everything across all of my machines. Not really sure what happened there, but we are back up and running. So, Kellos, good to see you. How are you doing? Hope you're doing well. We are going to pick up where we left off on the last stream and moving away from the render graph and making a bespoke renderer for our application, in this case, our game. So we're setting up sort of our specific renderer for this, and then we'll use that for the other game templates that we have as well. And then we'll go ahead and pull out the render graph because we don't need that anymore. But before we get into that, I do want to just take a quick second and thank the supporters of the channel, starting with our elite partner, Javier Lazaran, followed by our partners, Goboys Inc. and Matt Osgard. Those are the highest tiers of subscription, over on YouTube memberships and Patreon, followed by the list of supporters you see here on the screen. They are a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for your support. It is greatly appreciated and helps me cover the cost of running this channel, things like hosting fees, software licenses, things of that nature. So each and every one of those little bits of help goes a long way. Of course, I would also like to thank the viewers of whether you're joining me here live on the Twitch side or the YouTube side, or if you're catching the VOD after the fact. Without you guys, this channel and this project would not exist. So thank you guys very much for being here. I appreciate you guys. Good to be seen, doing well, daily grind things. Nice. Yeah, I hear that. I've done most of that stuff, at least on my end for the day. So hopefully we can get some decent progress on this tonight. All right, so last time we kind of had everything in here sort of in line in our refraction pass, and I was like, I'm gonna need a way to sort of call this more than once. And so I did a little bit between last stream and this one just to sort of separate some of that out into a separate function. Excuse me. So the way that this is going to work, just as a refresher, is we basically need to do a refraction pass for each water plane that we have. And then we'll need to do a reflection pass for each water plane that we have. And then once we have all of those water planes, we'll need to do a final pass of the entire scene, including the water planes at that point, right? So this scene pass is basically going to wrap all of that up for us. And so that's just a static function that we've declared here. And we've got a number of things that we passed in. So I also did do a little bit of movement around of data in terms of our structures. But it's all, I think, pretty self-explanatory. It's not too different than what we had. The biggest bit is I actually took all of the skybox individual fields that we had here within the forward pass render data, and I put them into a structure just to make it a little bit easier to organize. And that is available here. So essentially, the scene pass requires the renderer, the frame data, the viewport rectangle, a handle to the color texture and the depth texture that we're going to be rendering to. The clipping plane, which in this case is called just refract plane, that should probably be refract clipping. Clip plane, clipping plane, clipping plane. Just to make that a little bit more explicit as to what that is. And then it requires skybox data, which is actually going to be the same. And then we also have this refraction pass data, which, just as a reminder, for that contains everything that is needed to render the actual refraction pass. So things like the view matrix and view position, the opaque meshes, the transparent meshes, Eventually some terrain rendering stuff, although I'm not going to worry about that too much right now, because I think we're going to be doing a lot of work to that in the near future. So if we go down and examine scene pass, I kind of had a left off here, finish pulling in properties, because we have a number of properties down here that we haven't quite pulled in yet. Things like the view matrix, right? Which the view matrix is actually going to be a little bit different depending on what it is that we're drawing. So we're going to have to think about that for a second. Projection matrix, that probably, we probably can just pass that separately as a property of its own. And then most of the other stuff that we have to pass is basically just this high level material data, right? So our view matrix, view matrices rather, and positions for our refraction and reflection, because we'll need those both. And then let's see, the only other one is going to be the render mode that we'll have to pass in. We'll also need the cascade split data, the directional light spaces. All that stuff should be calculated and just passed to this, right? We want to keep this as lean as possible. Let's see, is there anything else in here? I think that's probably it. We also have a little bit of a dry issue we need to address here. So we have opaque geometries by material, so we loop through that. And this logic is basically the same as the transparent version of it, right? So we need to split that out probably into a separate function as well, just so that we're not repeating that code. Yeah, and that should probably be about it. Okay. Appreciate, thank you for the hearts. For those of you that don't know, that's my wife, by the way. Okay, so we have checked this for correctness with a no check-in on it. I think that's because, that was one other thing I wanted to talk about. The concept of viewports. Because right now we sort of have this viewport structure that we're using, and we pass it into our renderer. And a viewport essentially contains a couple of things. It contains a projection matrix type, the projection matrix itself, and then also a rectangle, right? And some FOV information, near and far clipping planes. And I don't necessarily think that maybe a viewport is, the structure that we require here. Because whenever we pass that to the renderer, the only thing that the renderer actually cares about is this guy, right? And so I think, coupling these things together probably wasn't the right decision. So I think we're probably going to remove the concept of viewports in general and just have this logic wherever we need it, instead of trying to sort of figure out something else along the way. But that's neither here nor there. I'm probably not going to do that within the middle of this refactor. I'll probably do it separately. Is it comfortable for your eyes to have the blurred background? Yeah, I mean, it's not too bad, right? I don't have a very loud image back there, right? It's just this one. So, yeah, for me, it's fine. I kind of got bored with the solid black background, so... but if it really bothers you guys, I could probably change it. Okay. So I guess I don't think we really need that second buffer, so let's get rid of that. And let's just kind of continue working our way through this, right? So there's a couple places where we need two view matrices, right? So for the skybox pass within the scene, we need both view matrices, right? Depending on whether we are generating a skybox view from the camera or the inverted camera, we need both of those things. So we need them there, but then we also need them right here, right, for the material frame data. And then in addition to those, we also need the view position. So I think probably what we could do, I mean, technically we could get the position from this, right? But I'd rather have the ability to keep them separate. So I think probably what I'm going to do is just take them in as properties here, similar to what we did in the old sort of render graph node. And we'll do something like, I guess I should probably put it up here. So we'll have, let's see, mat4, and we'll do view matrix. And then mat for inverted view matrix. And then we'll have vec3. Did it need a vec3 or a vec4? I forget. Was a vec4. I thought so. All right, so we'll go ahead and take a vec4 there. And we're going to do view position and then vec4 inverted view position, right? And then we can just use those properties directly, right? So what we'll do is before we eliminate this code down here, just to sort of make sure that we got it correct, I'm going to take let's see, I need, there we go. Let's see, it comes after clipping plane. So we need view matrix and inverted view matrix, right? So that's going to be, what did we say that was? It was this. Oops. Okay, so we'll put that there, and then here we'll do reflection pass view matrix, right, for the inverted one, and then we need plane refraction pass view position, followed by plane reflection pass view position, right? So we have normal, inverted, right? And so now we can actually just come here and do, let's see. I guess we could probably just do view matrix for that one. And inverted view matrix for that one, right? And essentially what this does is, we'll address that fix me later. Essentially what this does is it zeroes out the position of the camera, so that when we are viewing the skybox isn't actually moving around, it stays put, right? So we render the skybox first without a depth pass, that way, or without a depth buffer rather, that way it always appears behind everything, right? We could, technically speaking, we could render it after the fact too, using depth, but I think it's just easier to do it this way. Okay, so the next thing is the projection matrix. We don't have the projection matrix, so we should probably fix that. And that is going to wind up, I think we should put that probably here. So we're going to do mat4 projection. That's going to be right after VP rect. So let's go render data forward data projection. Okay. So we've got that. Let me get rid of this left off so I don't forget it. And here we could just do projection. All right, let me catch up on comments here. Lou the Coder, good to see you over there on the YouTube side. The moment I see we're manually writing code for everything in the game code, how will things work once the editor's added? How does our game code then know what elements were added by the editor? Aha, you're touching on the reason that I'm switching things up a little bit, and on the next point that we're going to hit. Can you explain how that part works technically in game engines, how Kohi will manage it in terms of scripting, etc.? So that is a really good question. And it kind of leads me back to the reason that I'm doing this with the renderer and the reason that I am going to switch the scene to be driven by the application code. And the editor ultimately will be largely the same. So if you think about the way that an engine should operate versus the way that your game code should operate and the separation of concerns there, what does an engine really do for us, right? An engine provides us tools and the runtime capability to build something on top of it, right? It is basically nothing more than a set of utilities and a set of tools at this point that are supposed to kind of work generically, right? That being said, the approach that a lot of game engines take, a lot of modern game engines take, and even kind of classic ones tried to do this somewhat, but is they'll write some sort of deep inheritance or composition style entity component system, or if it's Unreal, it'll be a mix of both, that tries to be as generic as possible and off-put that problem to the game code, right? So they'll write this super generic solution that exists in the game engine, and then say, you know what, we don't know what kind of data we're going to be dealing with here, so let's just make all these interfaces and let's make all of these structures and things to manage memories and entry points and all this other stuff. Let's make all of that and then put that off, right? We don't care about that stuff. We're going to let somebody else solve the problem. When really, if you think about it, at the application level, at the game level, in your game code, you know exactly what types of data you're going to be dealing with, right? So, for example, you know that you're going to be dealing with static meshes, animations, or any other custom types the game comes up with, right? But furthermore, you're also going to need to know, you're going to know the way that you need to interact with those things. You're going to know how they should be loaded, how they should be presented, what custom things you're going to need to be doing. And when you start thinking about that, it's like, well, why make something that is one size fits all when it's never really a one size fits all problem without adding tons of complexity in the mix, right? Because the problem with a lot of these entity component systems is they have lots of code overhead, and there is also lots of processing overhead and overhead of memory fragmentation, things like that. What if we just skip all of that, completely avoid all of that, and allow the application to drive these things? Because the application knows what data it's going to be dealing with. It knows the types it's going to be dealing with. It knows how those things need to be organized. It knows how those things need to be accessed for the quickest rendering possible, for example, or how we need to be able to query those things. The application knows the answers to all of this stuff, right? So why are we going to make something that's super generic that we then have to tell it through all these interfaces and layers of logic how things need to be built when we already know the answer in our game code to begin with? So what we're going to be doing is we're going to be dispensing with a lot of that generic stuff, and we're going to be writing bespoke logic in our game code, right? Or application code. I keep saying game code, but it's technically application code, right? And the reason I say that is because we have our game runtime, and eventually we'll have probably an editor runtime, right? And so out of that, yes, there probably will be some components that can be made common or shared between projects, right? But if you think about it, if you're dealing with a top-down or 3D isometric action RPG, the needs for that are vastly different than they would be for a racing game or a first-person shooter, right? Those are all completely different in terms of the way they need to load things, present things, the optimizations you need to put in place. And so a one-size-fits-all doesn't necessarily always make sense there, right? Not at, without having the extra cost of all the complexity in code and the weight that code brings, to the performance table. So, in our case, we're going to be making a bespoke version of it. And probably what we're going to do also is we'll have sort of like a basic version of those things that'll be included with the test bed, sort of as a template that you could use to build a game. But the idea is going to be that you should really be rolling your own for the type of game that you're wanting to build, because no two games are going to, or no two game types are going to have the same requirements. So why try to make it all one size fits all if we don't really need to do that? I hope that answers your question. That was a really long answer, but that's how it's going to work on a very high level. And we're already tackling some of that now with the game-specific renderer. Okay, got some catch-up to do over on the Twitch side as well. Let's see, anyone have advice for an intern looking for full-time soon? My team member said I probably won't be able to get a full-time job since my team is pretty small and already full, but I could probably keep working as an intern. My responsibilities have changed recently, and I've been doing a lot of firmware, electrical, solving 16-year-old issues. It's been pretty strenuous work since my specialty is software. My free time, I like to work on game engines and games, but I think I want to do embedded software professionally. Okay, so that's great question, by the way, and I have an actually somewhat simple answer for you. Build up a portfolio of examples of your work, right? If you want to do embedded work, have some examples of embedded projects on your GitHub, for example. That way you've got something that is easily pointable to say, hey, I'm capable of this stuff. Here is an example of my work. That will help you way more than you realize in job interviews. It also depends, obviously, on the place that you're applying. I don't know how interviews for like embedded type work goes, as opposed to, the big FANG companies and stuff like that. Generally speaking, I don't think you'd have to worry about so much of like leak code type problems, because a lot of that stuff probably wouldn't apply at that level, right? So, the best I can say is have a strong portfolio, and then research the companies that you are going to apply to, and tailor your resume and maybe even your portfolio to those things to those places that you're applying for. And yes, it sounds like a lot of work, and it can be a lot of work, but it's paid off. It's worked for me in the past. So, different field, obviously, but yeah, I think if you're wanting to get into embedded, then you need to make your profile, full of embedded stuff. That being said, speaking of responsibility, right? I don't know what the job market for embedded is like. So if it's anywhere near as competitive as game development, you may want to have a backup / plan B that you can fall back on. Something that you're capable of doing just to be able to, put food on the table type thing. Have a backup plan for sure. Sakelo says templates. No. No templates. Find it's much easier to make the engine take care of the core things and the complex stuff handled by script. Oh yeah, I forgot to touch on the scripting point. I'll come back to that. My engine has its own generic script, but when I need to make complex stuff, I would need to call several engine scripts or write one game script for that. Yeah, I mean, so it's all a matter of perspective, right? I would not use, personally, a engine that is more geared towards first-person shooters to make a racing game, right? Doesn't make sense. Doesn't mean that you can't, but it doesn't mean that it's always the right tool for the job. And I used to be very much in the camp of make it generic, make it reusable, make it so that, you know, it's super extendable. And those things aren't bad ideas, right? But I found that more often than not, they tend to actually get in the way, especially when the project gets of a large size, right? So, you know, think about the actual problem that you're trying to solve. Think about the data that you're working with. Solve for that problem. Don't try to solve for, I need to make this a super, you know, extensible code base that has to work 30 years from now, right? For all these unforeseen things. Think about the problem that's right in front of you. Think about what you have to solve. Think about how the data needs to be represented and transformed, and solve that problem. I'm trying to build up my projects, but I think I would need to work on tailoring my resume for sure, since I have a lot of game dev stuff on my resume. Most places I get no response. Yeah, unfortunately, that's the reality of the situation, right? Especially in today's job market. I have been there myself. So, you know, unfortunately, you got to keep just applying, right? But whenever you do that, you know, don't just shotgun the same resume out to everybody, you know, customize it a little bit, because that will catch somebody's attention for sure. But if you go, you know, copy pasting your resume, you know, just a generic one out, maybe not, right? Somebody will pick up on the fact that you tailored it, right? Or that your resume speaks more to what they are looking for than just some generic thing with a whole bunch of stuff that doesn't apply. I hope that helps. Cry anytime I get an error message that comes from a file full of templates. Yes, exactly. It's gross. Major reason I stopped bothering with trying to make a plugin for Godot. Oh, I can only imagine. Yeah. Yeah, no problem, Lulu Coder. An idea for higher performance rendering is using frustum culling for top-down or FPS games. Yes, exactly, right? But the needs would be different between the two, right? So, for example, you would have frustum culling for both, right? But your frustum would probably be vastly different between the two, right? Because you wouldn't need to have the distance for a top-down game that you would have to have for a game like a first-person shooter that needs to look way off into the distance, right? So that generally means that you can spend more resources on putting in closer details that don't necessarily have to be optimized to the point where they would have to be for something where you can look out half a kilometer away into the distance and stuff. You know, it's very varying requirements between what you're doing. You know, you could also for a top-down game, you could also have like a tile-based situation where you could just essentially move a box over the scene, and anything that's in that box gets rendered, and anything that's not inside that box doesn't, right? And it becomes even simpler than using a frustum in that case, even though it technically kind of is one. You know, you don't have to worry about quite as much complexity there. But yeah, I mean, again, it depends on what you're doing, right? Jeet, how's it going? Good to see you. Same here, 8 years of experience, 9th iteration of my resume, and I'm finally getting 1 to 2 calls per 2 weeks. Nice. Yeah, I mean, it's just kind of a crappy market everywhere, right? Unfortunately. Yeah, I got laid off last year, so yeah, I know all about that. Let's see. Okay, I think I'm caught up. How about only renders objects while they're in the frustum? Yeah, exactly. Yep. Okay. And by the way, we are going to be doing that. It's not something that, well, actually, I mean, we already are doing that. So in our case, we actually perform the culling before the data even gets sent over to the renderer. So in our case, it's going to be already done by the time we get to this point. Okay. So let's see, we need delta time. Oh, projection, we already have that passed down. We can use that. Then we have, let's see, the refraction pass uses the regular view matrix, so we can use that. And then the reflection pass uses the inverted view matrix. And then, again, we have refraction first, so this is going to be view position. And then we have inverted view position. Render mode, we are not passing in. So I don't think, let's see, that's in the forward data. I don't believe. Yeah, we probably ought to add that in here. Probably somewhere towards the top. What was that again? I think it was a U32. Yeah, it was a U32. All right. So let's put U32 render mode. Oops. And we'll do here, we'll do render data, forward data, render mode. Okay. So we have delta time and game time. Those are things that the material is going to need to know. Oh, I forgot to actually feed that through. So we're going to need delta time and game time. Those are both, I think, 32-bit floats. Yeah. And then we also are going to need the cascade splits, which are, cascade splits are basically are sections of the view frustum where the shadow cascades are displayed in terms of, you can think of it almost as percentage, right? How far into the frustum do we split from one cascade to the next? And then directional light spaces is basically the directional light, what's the word I want? Matrix in light space. And we have one of those per cascade, right? Because the light space is different for each one of those. So that is going to wind up being something, we probably ought to just pass all of those in at once, I think, because we are going to need them all at this point to pass to the PBR shader. So how do I want to do this? All right, so I guess I'll do, let's put, let's do vec4. Or was that a vector 4, or was that a array of floats? I mean, it doesn't technically matter, but yeah, it is an array of floats. I thought so. So F32 cascade splits, and then F32, mat4 rather, mat4 directional light spaces, right? And that should be, oops, those should both be 4. Helps to put the T. Just doing it up on the dingus-oriented programming tonight. All right, so scene pass. So these are going to be passed in just before the skybox data. Okay. So render data, forward pass, or forward data rather. And then we need cascade splits, and then render data, forward data, directional light spaces. So pass that through. And then delta time and game time. we should probably add those as well. So I guess we can probably also put those up here. Let's see, so we'll put cascade splits there, direction light spaces there. So we still need to get shadow. We still need to get shadow bias in as well. So I guess we could probably put that here with the shadow information of 32 shadow bias. All right, we'll pass that in instead of hard coding it. Right. All right, let's go back up to where we call it. So that needs to be, shadow bias needs to go here. And then where exactly did game time fall? I think it was after frame data. So game time and frame delta time, I think it was. Game time, then delta time. Make sure I got those right. Delta time, then game time. Got backwards. That would have been bad. Okay. So we only have a couple of things left here to work on. This is for the irradiance cube map. So this technically is also an array of 4. So I guess I could just, let's do this. In fact, I probably ought to do that for all of these things. Oops. There. Right, this should probably be material max shadow cascades, as well as this. No magic numbers. Okay, and then we just need to put in, what is it? Forward data, irradiance, keep map textures. So right there. Right. I guess we don't need that. And then all we got to do is shorten that up a little bit. All right. So that's that. So now all we need to do, in theory, I think there's actually a couple places, I'm gonna have to double check this code, where we were passing things directly as part of the, like we had hard coded some things. So I just gotta quickly review this and make sure we're not actually doing that. Can you have multiple frustums and dedicate objects, and dedicate objects for, one for textures or light? Okay, I think I see what you're saying. So, I mean, we do have multiple frustums, right? So, our directional light actually has, technically speaking, it has multiple frustums, right? Because we have to render our shadow map from 4 different places, right? As they get closer and closer to where the camera is. So there are 4 frustums that are used for that, in addition to the view frustum that is used to actually clip geometry for the camera. So we do already have that. We don't have, and that's one thing that I want to resolve with our scene refactor, is we don't have a concept of masking yet, or layering. And so, where we can turn certain things on or off by a mask that's applied to them. And that could be determined as to whether or not it renders or not. In addition to like a renderable flag or something that we could use in an editor, we're going to need to add all that stuff, I assume, at some point. But we probably will only add that when we actually need to use it, right? So the rule that I'm trying to follow is at this point, we're trying to batten down the hatches and only put in stuff that we're actually going to use. Not saying we won't ever use it, but if we need it, we'll put it in. All right. Yeah, so that's kind of the plan anyway. So let me just look through here. Make sure, you know what, I think, let's see. Here's one of them, right? So we had a refraction or reflection view index here. And this will basically tell us what index to use, whether we're rendering refraction or reflection. And that will make a big difference in which one we use. I think that might actually be the only thing that we have left, which is good. So we do need to put that in. I guess I could call it view index. So let's see, where do I want to put this? I guess I'll put it here. Oops. So U32 view index. And then I'll do note 1 for, 0 for refraction, normal, regular rendering, 1 for reflection. Right? And then that means here we can just put view index. I'm actually going to remove that comment from there, and then we also had it here. All right. Cube map index, there is a fix me in there. I'm not going to worry about that for now. We only have one in the scene. Again, that's going to be something that I thought about in terms of the design of the shader, but we'll add it. We'll add actual support for it if we need it. So that was the, let's see. Right before cascade splits. Okay. So right here. So the view index for this, it's a refraction, is going to be 0. Right? And actually, let's make this a little bit more explicit, right? Because 0 is not very descriptive. U32 view index equals 0, right? And again, we'll put note 0 for refraction, regular rendering, 1 for reflection. And then we'll go ahead and just put view index here. Now, the nice part about moving this to a function, right, is now we can actually say, we can take this whole block of code, and all we're doing now is essentially duplicating the block of code instead of all of that other stuff that we had before. Oops. So we can get rid of that left off, get rid of the to do, and get rid of this note. No, I can leave that. That's fine. All right. And so actually what I'm going to need is I'm going to need that render graph node forward render pass. And I'm going to need render scene. And we had in here the clipping planes for this. I guess I need to look at the calls for render scene. Yeah, here we go. All right, so that's the refract plane, right? So now what we actually need is we need the reflect plane, right? So we're going to call this reflect clipping plane, right? And the view index here is going to be 1, right? And so this basically just means for the refraction pass, everything above this plane is going to get clipped, aka not rendered. For the reflection pass, everything below that point is not going to get rendered. And we're also going to use an inverted camera, right? So this is going to be reflect clipping plane, and that's all we have to do, right? Pretty straightforward stuff, I think. Now we do have a to-do here. We obviously should not be hard coding this, right? We should be using the actual position and orientation of the water plane, but for now, we're not going to worry about it. All right, so the next thing that we need to do is we need one more pass once all of the water planes are rendered, right? So remember, this is all part of rendering the reflect and refraction for each of the water planes that we have in the scene. So we do support multiple water planes, right? So if we have multiple of them, we can actually handle that. And so once all of those are done, then we finally come to this, what I call the standard pass. And then this is going to be essentially the same as the other two, but without a clipping plane. And it's going to render the water between the opaque objects and the transparent objects, right? So it's basically going to render opaque, then it'll render the water planes, and then it'll render the translucent objects, right? So that's essentially what we have to do here. And that's going to get a little bit tricky, right? Because we don't actually have that information in our scene pass yet. So we actually have to put that in here somewhere. And this is going to be the last set of properties that we have for this, which is good. And I think what I'm going to do is I'm actually going to add this one to the end here. And what we're going to say is, let's see, actually, what we're going to be dealing with is an array of these, right? So let's just take this, come down here, and one more, and slam that right in here, right? So we're going to say planes. Let's actually say water planes, and we're just going to put a const tag on that as well, right? And so we have that. And then we'll also have U32 water plane count, right? And so essentially we're going to use this water plane count in the array of planes to trigger whether or not we actually draw those planes, right? And so those are going to be, let's see, right... Skybox, let me see. Skybox goes first. Always. Okay, opaque, right? So water planes will go right here. So if water plane count and water planes, then we'll go ahead and render them, right? So put a to-do here, do the thing. We'll come back to that in a second. So what we need to do here is put, let's see, let's actually go to the top of this loop. Because I think that was part of the forward pass data. Oh, scroll back too far. Okay. That's all the shadow pass stuff. I should probably split that into a separate function too, just to kind of make it a little easier to digest. Okay, forward pass. Here we go. Water plane count. There we go. And then water planes. You know what? I'm just going to actually copy this for a second and come down here. And I'm just going to paste these here. And we're going to do, let's see, render data, water plane count, comma, and then we're going to do just the water planes without the sub W. And then this needs a comma after it. And then this needs the semicolon deleted. Right? Now, I've put this here, but it actually doesn't belong there. Come to think of it. So this is the refract pass, right? So what we actually need, I'm going to copy this again, because this is most similar to what we're actually going to be doing. I'm going to take a copy of this, and I'm going to come down to here for the standard pass. I'm just going to paste it, and we'll come back. Because these should actually be zeros for the refraction pass, right? So 0, 0, right? And the same is going to be true for the reflection pass. Right? Okay. Now, the last clipping plane that we need is actually going to be no clipping plane. And how you say no clipping plane is basically a vector 4.0, right? That indicates no clipping plane. Let's see. Viewport rect. This should be reflection color, which we don't have yet. That was almost a nasty bug. Because we actually need to get these from the material. We haven't done that yet. Let's take this and let's just go down here. Right, and I'm actually just going to space these over for a second so I could just do this. And then this is going to be the same there, right? So reflection, this is going to be reflection, reflection. Now we'll format it, right? Okay, so reflection, we didn't change it here either. So this is the reflection pass, right? So this should be using the appropriate handles. We also need to make sure that we're using the right pass for all of this stuff too. So, well, these are all going to be correct because those are always going to be the same. So actually those are good. We do need to just change this one here. Okay. All right, so that all looks good. Now, let's see, clipping plane, why is this bleating? It doesn't know about vector 40. We didn't have math. Okay. All right. So obviously we're gonna have to change the clipping plane, right? So that's, oops. So we use that clipping plane. And we are going to be using render data, forward data, and then I think we have, just view matrix here, right? So we have the view matrix that we're going to be using for that, and we are not going to be using an inverted one, right? So we can actually just, pass anything here, technically, because it's not going to get used. I guess what I could do is mat for identity, right, with a fix me. Cache this, right? So that's going to be that, and then also going to be the same for this. So we want to do vec for 0, right? And then this is going to be render data. Let's see, did we not? Oh, forward data, view position, right? So we just use the base data for those. The past data, though, I don't think we actually have that. So render data, we might need to adjust that a little bit on the structure, because I don't think we actually have. Yeah, we only have these listed out, which is not what we really want to do, right? Okay. And actually, I just realized we don't need to pass. I think there's a few of these parameters we can actually eliminate. But so what we're going to need is forward data, and then instead of a water plane pass, right, we're actually going to need something that houses these opaque and transparent meshes by material. So I'm going to put that for there. That doesn't exist. We're going to have to figure that out. All right, let me catch up on chat real quick. Every so often I see, every so often I test by making a game devs pwned. This is way more leak code than leak code. Yeah, I do get that for sure. How's it going, by the way? Welcome, first time chatter. Hope you're doing well. Let's see. We got some comments over on the YouTube side. Why doesn't C, C++ have modules? 99% of compile time is just parsing include hell.h. C++, modern C++ does have modules, but let's see. Hello, I want to thank you for great content you uploaded in the past. Learned a lot from you. Awesome, I'm glad to hear it. Good to see you in the live stream as well. Yeah, so I mean, C is pretty lightning fast, compiling anyway, so I'm not too worried about it. I also try to, as a rule, not to include headers and other headers whenever possible, and it helps a lot with that. There's some places I definitely need to fix that, though. Have you ever hacked a game? Yes, I have. But it depends on what you mean by hacking, I guess. I've not really done much network hacking in a long time, but asset hacking and stuff I've definitely done. modding and stuff like that. Absolutely. Yeah. Maybe in 10 years we'll see real usage of them. Yeah, I guess. My fear is that if we go too heavy in the module direction, I just don't want it to wind up like... Well, I will withhold that comment, actually, because I don't want to go down that rabbit hole. We be using Jolt physics or rolling your own. So for this game, we don't really need any sort of complicated physics. All we really need in this game is some basic, and I do mean basic, collision detection. And then we need the ability to essentially move around on different walking planes. So what I mean by that is think of games like your God of War or something like that, where you're kind of bound to a platform, and that platform can have, waves in it or ups and downs and things like that. And then you generally transition from one platform to another. That's essentially what we're going to be doing. So our movement will be constricted to those individual planes. And then we'll be able to transition from one of those to another one to so for example, let's say you've got a low area and then you've got, above that, you've got a high area with a ladder connecting. The low area would essentially be some geometry that you could walk around on. And then the high area would be geometry that you could walk around on. And then the ladder connecting those two would just literally be a linear path that you would follow to go from the bottom to the top with some animations and, over time. Probably while you're holding a button down or something like that. And then you would, so you'd essentially transition from walking to climbing to walking up here. And you don't need any advanced physics for that. We're not going to have like any kind of jumping to get into weird places or things like that, because that all tends to be huge vectors for bugs. And I'm the only one working on this game, so I have to avoid stuff like that. So we're not going to be using any kind of advanced physics for this game, but that doesn't mean that we won't in the future. And so essentially, when we do get ready to do that, it'll be a plugin. And more than likely, I'll probably use Jolt. I might have a Jolt plugin. I might have a Bullet plugin. I might do both. I haven't really decided. But yeah, Jolt looks like it's pretty sweet. Okay. So there was a bit of logic in here. Having to do with the viewport. Where was that? I thought it was this one, maybe. Maybe it's not. Right, we did a viewport set. Bind the viewport. This is what it was. So we had an internal viewport that got set. And all the render active viewport does, literally, is the same thing that we're already doing in here. Which is this. So cache this somewhere and pass it instead. Yeah, I suppose we probably should do that, but I'm not going to worry about it for now. Okay, so let's see. VP rect is there. Let's go with... Do we actually get past that? Render data. Yeah, we do. We do. So we can actually just use that. And then we don't need to do this. We'll still keep this. We'll still keep that just for clarity of what's going on. Now, what are we going to be rendering to? I don't believe that we have actually provided that anywhere. I don't think. Render data, forward data. Nope. We have not. Okay, so we're going to have to go to our render data, or specifically our forward data. And we're going to have to add some targets here, which technically speaking, this could change. So we want to keep this flexible, right? Because if we're rendering to a texture or something like that, we need to be able to actually do that properly. So we have VP there. And then we also need a K texture. We'll do color buffer. And then K texture depth buffer. All right, and so now we can go back here and just say, oh crap, we don't have the handles to it. Okay. K handle, color handle equals texture renderer handle gets, and then we'll do render data, forward data, color buffer. And we'll do the same for the depth handle. And this is going to wind up being depth buffer, right? And now we can just say that. All right. The last piece of this is this standard pass bit that we've discussed here. So before, we kind of had this concept of, how are we going to handle, ooh, you know what? I just actually thought of something too. For the render mode stuff. I'm going to put a to-do here before I forget this. To do, or I guess I'll do a fix me. If render mode is not normal, or is not regular, I think we call it, there is no need to perform the refract passes. And what that means is the renderer mode is essentially a sort of a debug mode that we have where we can view the normals, view the lighting only without the color of the textures, wireframe mode, stuff like that. So if we're not rendering in sort of the default or standard mode, then we don't actually need to be watering the water or rendering the reflection and refraction planes of the water anyways. It's just wasted work. Okay, so what we need to look at is we have this water plane render data, right? And within each one of those, we have scene pass render data. And so each one of these contains all of this stuff. So this contains opaque meshes by material, transparent meshes by material, and then the height map terrain stuff. So what we need to do is actually reuse this structure in the forward pass render data instead of all of this stuff, right? Basically just, or I should say all of this stuff. It replaces all of that. It's a drop-in replacement, right? So we can do standard pass, I think is what I called it. And then this is data to be used after reflection, refraction passes, right? And so we don't actually need all of this because that is all contained in this guy. I didn't realize I'd already kind of done that already, so that actually helps quite a bit. All right, so let's go back here. And yeah, there it is right there, standard pass. So now we can just pass that in, and we're good. So I should probably also have this here. Okay, so just to recap, let's see, this actually, let's remove the to-do. All right, so just to recap the way that this all works from the top. Let me actually, yeah, I'll go all the way to the top actually. So when we render a frame, where we're at right now is we have a begin frame, right? So that doesn't do anything now, but it might need to in some future part. So we just set a debug label on it and move on for now. We clear the color buffer. We clear the depth stencil buffer. And then we do the shadow pass. The shadow pass iterates all the cascades, draws all the objects we need to, etc. Right? That's what that one does. So it creates the shadow maps for us. Then we have the forward pass, right? So this technically consists of several subpasses. So what this does is it loops through all the water planes that we have. For each water plane, it has a refraction pass, which renders everything below the water's surface, refracted by the water's surface, essentially. And then we have the reflection pass, which renders everything above the water's surface, but using an inverted camera that's looking kind of below the water up, right? And that's how we get that reflection. And so we render that for each water plane as well. Once we have rendered all water planes, then we perform another render pass over the entire scene. This one actually rendering the water planes themselves. So the first two passes don't do that. They render everything in the scene except the water planes. These ones render the water planes themselves. So that is, I think, the last bit of logic that we actually have to add to the scene pass, and I think we're basically done with that at that point. So that is going to wind up being right here. So let's take a look over here at our render scene, and I think we actually had... I could have swore that we already actually had something in here for that. It might have even been called like something like, let's see, water drawn, render water planes. Here we go. Okay. Looks like this has got a lot of stuff commented out in it too. So let's actually take that debug label though. Let's go ahead and put that in here. And let's see, plane count. We already have that check here. Okay, I guess we could do this. Essentially, this is all it is, though. In fact, I'm actually just going to lift this. Well, maybe not exactly like that. I'll lift this out of here. Slam that down, take this. And just before we end out of that one, we will end the debug label. Okay. So let's shove that back over to the side. So water plane, we're not going to be using water planes directly. This is also going to be water plane counts. So water planes sub I. That is going to be, I'm just going to take this and go here, right? So we've got a pointer to the water plane, right? The material instance, let's see, it's going to be plane material. Why is this bleating? Oh, probably because it's const. Sure. Okay. Material system apply. So we need the renderer material system for that. Okay, that's just that. View index. Let's see, that says it should be passed in. However, it is safe to assume a 0 index here because we are not doing a refraction pass. So that is perfectly fine to do. Apply instance, that's going to be the same thing there. In fact, this is also going to be that same thing. So that is actually it for water planes. All right. Thankfully, our code just kind of fit. All right. Cool. So the next thing that we probably ought to do before we progress any further, because I think this is actually all we have to do pretty much for the forward pass. What is this complaining about? Oh, it does not control it. Does not return. So I think that's supposed to return a Boolean. Okay. So I think that is the end. Pretty much the end of the scene pass. So the other thing I want to do is we'd mentioned before that this was sort of a duplicate. So this and this up here are duplicates of each other, right? So we probably ought to refactor like both of these loops or move them off into a function, and that'd make it a lot easier to sort of deal with. So let's do that. SciCode, how's it going? Good to see you. C++ software is more work figuring out your build system than coding. No kidding. C can be that way too if you have something complex, for sure. Singy, good to see you over there on the YouTube side. How's it going? Let's see. Do you know the feeling after checking on a code base that you feel or don't feel home, like the style, etc.? When reading your code, it feels like I wrote it myself, sometimes very wild. Awesome. I assume that's a good thing. Why didn't C++ fix forward declaration yet? 50 years of legacy. Well, legacy is a big part of that, right? But what do you mean by fix forward declaration? The fact that you have to do it? C++ build system is way better now. So many solutions to pick. Yeah. It depends on how complicated you need to get with it, right? Don't get me started on MSVC forward declaration. Yeah. I was just wondering what part of it they're talking about. That's all. All right. Okay, so I do want to separate these things out. See, are there any other opportunities for this? I don't think so. At least not yet. But this one is worth taking. So I think what I'm going to do, I am actually going to take this as what I'm going to make the function. And I guess I'll go, maybe I'll do this right above this. Incidentally, I normally do not advocate for having a function with this many input parameters, right? And in fact, some of those we can't actually get rid of, and we're going to get rid of. But it's static. It's not a public-facing function. We only call it internally from two places. And it keeps us from repeating a bunch of code. So I'm really not that worried about it. If it was public-facing, though, absolutely not. All right. I guess I could make this return a Boolean too. What am I going to call this? Draw geo list. I think that'll work. So I'll just go ahead and paste that, right? So we're going to have U32 mesh by material count. And then we'll have alumina material render data materials, right? This should probably technically say geometries by material count, because that's technically what we're doing. I might rename that. But now we no longer have this opaque stuff, right? It's just whatever we pass it, right? Oh, meshes by material. Sure. Okay. Let's see. We're going to need a couple of other things with this. The renderer is going to solve a lot of it, so let's get that in here. Let's get that. It's going to solve most of the issues, actually. Let's see. So we need view index, clipping plane, and p-frame data. So let's put p-frame data first. We'll do view index, I guess, will be next. So U32 view index, which doesn't need to be a U32, but it is in the shader code, so heck with it. And then clipping plane will be a vec4 clipping plane. Okay. Oh, and then return true, because we do have some falses in there. Okay. So now we can just grab this and go back down here. Let's see, here within our water planes, here we go, transparent. Here we go, opaque. Okay. So let's just paste this here. Right, and we're going to say draw geolist, obviously pass the renderer, pass the frame data as is. The view index should be passed in, clipping plane should be passed in. So the material count is just going to be this. Right, and then meshes is going to be pass data, opaque meshes by material. Right, we'll check the results of that in a second. Oops, did I? Right, because I copied that before. Okay. All right, so that is going to replace that, right? So now we can just say if not this, I don't know, we'll say failed to draw opaque geometries. See logs for details. Turn false. Right? And the cool thing is right after the water planes, we can actually come down here and do the same thing, only this time transparent meshes by material counts and transparent meshes by material, and eliminate this whole block of code. So now it's a little easier to see what's going on, right? Let's see. In MSVC, they let you forward declare enums or allowing templates in CPP instead of .h. Both not in standard. Wow, I would never do that. I try to avoid stuff that's not standard, because that just sounds gross. Why would you? But why though? Good old Microsoft, always bending the rules, right? Speaking of Microsoft, actually, hold on a second. I actually have something that's pretty funny. Happened to me the other day. Let me see. Let me find it. Some of you guys might have seen it. Split this off into a separate window. So the other day I put a post where I was like, I walked away from my work machine and I'm like, I'm just going to put this to sleep so I don't have to reopen everything in the morning, because my job requires me to have a lot of crap open all the time, right? And Windows is basically just like, no, you're going to take Windows updates and just reboot and throw out all your state right out the window. And it just does it overnight and I have no control over it. Then I turned on my computer this morning and it instantly blue screened first thing when I turned it on, because I came in and it was shut down, right? It just like installed its updates while it was asleep and shut itself down. And so, you know, I tweeted about this, and then Microsoft support like picked it up and like responded to it twice. Pretty funny. They were like, hey, we saw your message. We're here to help. That reboot plus blue screen combo can really shake up a smooth morning. What a way to put that, right? And then let's sort it out over DM so we could dive right in, right? And I think this is an AI thing. I'm pretty sure it is. It's an AI bot, right? But like they actually pinged me a second time because I didn't respond the first time. Just very funny. Microsoft. Forward declares can be useful for node trees and such. Yeah, I mean, I do use forward declarations, but not in that way. What is your Linux distro? Arch. I'm on Arch. And my machine name is called Arch, by the way. So that's why you see that down here in the lower corner of the screen. Arch, by the way, yeah. I actually had people asking me if there was an Arch, by the way, distro, because they saw this down in the center, or the corner of the screen. It's very funny. They're like, where did you find an Arch, by the way, distro? I'm like, no, it's the name of my machine. Very, very funny stuff. Love the post. Repeat after me. Update, update, and shut down, update, shut down, update, and restart. Yeah, exactly. Yep. Yeah, and I'm just like, I put it to sleep because I didn't want it to restart, and it's just like, nah, I'm gonna do it anyways. I got you, bro. And then it just shuts down, and then I boot it up in the morning and it blue screens. Of course, now Microsoft is removing the blue screen, so that's probably the last blue screen I'm ever going to see, because I've heard that they're changing it to a black screen now. So, but yeah, there's a reason I daily drive Linux instead for my personal stuff. Linux users, when they hear about a just released distro that only 2 people know about, yeah, true. Is it Hyperland? No. I'm actually using KDE Plasma at the moment. One of the reasons I'm using this and not something else, I am on Wayland, by the way. But one of the reasons I use this one is because I have varying DPI monitors. So I've got my main display is a 4K display, but I've got 1080p displays off to the side. And a lot of desktop environments do not like that or do not handle it well. And fractional scaling is rubbish in X. So, but with Wayland / the way they've handled it in KDE, it actually works really, really well. It even works better than it does on Windows, because Windows kind of snaps between the DPI as you like move your window between monitors. Mac OS does an okay job of it, but this is the best I've seen by far. Been using KDE for a while. It's honestly pretty good. Yeah, I switched to it a while back because I was using Cinnamon for the longest time, because Cinnamon on X11 is actually also pretty decent, but it's not as good as this. Don't install all the meta tools, only necessary stuff. Yeah, I made that mistake and installed a lot of the other crap that came with it, and I've been removing it as I find them. But KDE was leaving tabs in my IDE on Alt tab for me, and I had to switch distros because I'm a noob. Yeah, I mean, every desktop environment has its issues, right? They're not wrong. It did shake up a smooth morning. Yeah, that's true. It sent me into an instant rage first thing in the morning. Great for my blood pressure, let me tell you. Anyway, all right. So, we are actually done with the forward pass, I believe. Let me see. Let me just have a quick look through the forward render graph node. I think we actually are. Wait a minute. No, there's a couple other things I think that I need to do. Maybe not, actually. Let's see. End rendering, water planes. I don't need this exception case anymore. Forward render graph, node execute. So these are the old ones. Okay, so I didn't do this, I don't think. So let's see, we have scene pass. Right, okay. So there is one more thing I have to do. At the end of each water plane, we essentially render to these render targets right here, right, for the refraction, reflection, right? At the end of this, we need to perform a little bit of logic to get those textures ready to be sampled from, right? So in this case, we just need to make a simple call to the renderer to say, hey, we need to prepare this for sampling. We also did, let's see, what are these flags? I forget why I had to actually do this bit, but I'll go ahead and just stick this up here anyways. Right? Oh, and this is not going to be our renderer. This is going to be the renderer state that we want to use. There we go. Okay. So we need to prepare those textures to be sampled from. Otherwise, they wouldn't be in the right image format. I suspect we have some debug label issues that we're going to have to sort out too, so I'll have to check that. So that's that. Standard pass. Right. Okay. I think that actually is it. I think that actually is it for the forward pass. All right, great. So let's look at app config. So we've done frame begin, we've done clear color, we've done clear depth stencil, we've done shadow, we've done forward. So the ones we have left are debug, editor gizmo, standard UI, and frame end. Which none of those are really complicated, right? Those are all going to be pretty quick to port over, I think. And I'm taking these as is right now because this is actually the flow that I need. We're obviously going to build on top of this, but that is essentially what we are doing for now. So let me see, is this is the forward pass. Okay, so next is going to be debug. Let's put to do. Debug 3D. And then we want editor gizmo. And then we want, let's see, what's next? SUI. Oops, no, stop that. And then instead of do the thing, we'll have frame end. You know what? Let's do frame end first, because I know that one's going to be pretty simple. So let's take this one. Let's see. So in the creation, let's see. We just read the config, set up sources and sinks. Okay, we don't have to do any of that. We don't have any resources to load. We don't have any initialization to do. This is just debug labels only, actually. So that's really stupid simple. Okay. Right, so we'll do that, and we'll do frame end. Intentionally a no op for now. That's fine. Okay. So, the next one is going to be SUI is going to be kind of complicated, I think. It's not terrible. It's not uncomplicated either, though. We're going to have to do some shader uniform stuff. We do have resources to load. Although that is actually just setting up sources and sinks. Why did we do it this way in this one? Yeah, this just uses the same attachments as passed in before. Okay, so I don't really think I need to worry about that. Okay. So I guess really it's just initialize. All right, so we get the standard UI shader. We grab all of the uniform locations. Probably need to clean that up and make that a little bit nicer when we port it over here. And then the execution. So we do a begin debug label. We go ahead and grab the handles of the textures that we need. Begin rendering, viewport, disable depth, test and write. Use the shader, apply the per frame data. This is all pretty standard stuff actually so far. Get the renderable counts, loop through the renderables, set the clipping mask if we need it. So if there's a clipping mask, that is what all of that does. If there's no clipping mask, then we essentially make sure that these things are off. Then we apply the group, which I do have a note in here that I need to kind of simplify this, and then the per draw data, and then the draw. Oh, this is not actually complicated at all. This is actually pretty straightforward. Okay. So let's go ahead and knock out the SUI then. I'm just going to wait on this, but... Okay. So I think what I'm going to do is I'm actually just going to grab all this code out of here. Just going to copy it. Including up to the end of the debug label. because I think a lot of this code is just going to drop right in. We just have to rename a couple things. Okay. So forward data did have textures that we're going to render to. Standard UI is also going to need that. So let's see, we're going to need color buffer texture, depth buffer texture. And that's used for stencil purposes, right? We're going to need a viewport. That makes sense. We're going to have to store the SUI shader. Oh, right. We're going to have to do some initialization around that too, because we need to get the SUI locations. Okay. So this is the part. This is the part that I think probably shouldn't be in here, right? All this SUI stuff. I feel like a lot of this should just be fed to the renderer as like raw data that we're going to render, right? Buffer offsets, settings, vertex counts, things of that nature, right? We do have these SUI per draw UBOs here, though. I think that's probably fine. Like any shader level stuff's probably fine. Although I don't think those are defined anywhere outside of here. Right. Shader locations. Yeah, I mean, I could move all this stuff, I guess. I guess I could move it over because, like, we're going to be reworking the standard UI at some point anyways in terms of how that's rendered. So I suppose I could just leave it this way for now. And then when we rework it, we could just figure it out then. Let's see. First time chatter, welcome, by the way. Do you use RenderDoc for debugging? Yes, I do. Quite often, actually. It's funny you mentioned that, actually. I was debugging something else. I actually have it open already because I was working on something else earlier. Let's see. Arch is so nice since I don't have to deal with 10 different package managers or install different repositories, and just install what I need and don't get confused by clutter having 5 different network of managers. Yeah, as I was reading that, I was figuring you were talking about Ubuntu. SkyUp is saying that they personally like Windows Package Manager for downloading random exes from the web. I mean, parts of it are okay, right? Like, it should have already kind of existed for a long time, but it tends to have issues too, because there are certain programs that have really bad defaults when they install, and so you have to like run them in interactive mode. So there's some weird things around WinGet that you have to do sometimes. It's not always quite as smooth as it is on other platforms. Since you have an RTX 2080, you can also use Insight. True. I've had limited success with that on Linux, though. I have gotten it to work before, but it's kind of a pain in the ass. So if I were to use that, I would probably have to boot over to Windows, just because, like I said, it's kind of a pain in the ass. Okay, so a lot of this stuff should be stored in the renderer state. So, well, some of it's going to be stored in the state, some of it's going to be stored in forward data, right? So this is the actual render state here. So what I'm actually thinking is we probably ought to do similar to what we've done for the others. Type def, struct, Illumina, SUI, pass, data. Illumina, SUI, pass data, right? And so this is going to include, khandle, SUI shader, and then it's also going to include these locations, which I'm not going to wrap these in a different struct this time around. What we'll do is we'll just say instead of having that, we're just going to say location, right? So we have locations on all these guys. And then we're also going to need to know in the pass data, the color buffer and depth buffer texture. So the pass render data, rather. Let's see. So this is where the split's going to be, right? So these are the things that we want to maintain as part of the renderer state. And then there's things that we're going to want to always pass in because they could change, right? So we'll do SUI pass here. And then in let me find it. Illumina render data, right? So this is sort of the grand structure that oversees everything. We have like the shadow cascade data, and then we have the forward pass render data, right? So here would do a type def. What is with me not being able to type def tonight? Struct Illumina SUI. What did I do? Pass render data. Right, so this is going to be stuff like K-texture, color buffer, K-texture, depth. Yeah, let's do depth stencil buffer because we actually do use the stencil on that. K-texture. UI Atlas, that probably should be. UI Atlas should probably be part of the UI Atlas should probably be part of this guy up here. K-texture, UI Atlas. And then what else do we need? So we're going to need a viewport, which again, we're probably going to wind up getting rid of viewports in favor of just using rectangles. And then we need a map for view. And map for projection. Mat for. And I think that's going to be about all we need at this level. All right, so down here, we're going to do SUI data, right? So we've got the sort of permanent state data that's in our render pass data, and then we have our render data that gets passed in every frame that can vary, right? And so, yes, technically speaking, we could change these, right? I don't know why we would, but I'm not going to rule it out, right? The viewport can and will change, like on a resize. And then, of course, view and projection could change as well per frame. So we're not gonna maintain that state within the renderer. We're gonna just pass it in. Okay, so in create, we're going to want to probably go to the end of this. We need to set up the SUI pass state. Right, so out renderer SUI pass, and then SUI shader. I'm pretty sure we actually have something out here to get the shader. I thought we did. Yeah, shader system get. There we go. I'm actually just going to use this as sort of a template. So let's actually just do this. And let's actually scope this as well. Right. Okay, so this is going to be, oops. Thought I hit escape, must not have. All right, so this is going to be SUI pass. And then this is also obviously going to be that as well. And then this is going to be, well, we'll come back to that. All right, so SUI shader. And then this is going to be shader name runtime. This is going to be, crap, what was it called? I think we have it in here. Shader system get, here we go. There we go, standard UI. Let's, you know what, I'm just gonna copy this. So I'm gonna go here. And just paste that there. And I'm also going to make sure that we have the correct include, right? So this is going to be, let's see, frame UBO location, right? And that's going to be obviously SUI pass, SUI shader, and oh, you know what? Why don't I just do this? Right? Why don't I just do that? Out renderer, right? SUI pass, and then remember I renamed these. Right, so we could just do this. Right, and then instead of internal data SUI shader, it's going to be out renderer SUI shader. Is it not SUI shader? No, it's SUI pass, then SUI shader. There we go. Okay. Okay. So I suppose we could check all of these, right? I don't know that I'm going to really bother. I'm just going to kind of check the first one, right? So we'll do SUI pass frame location, fail to get uniform location for SUI shader dots frame UBO location, whatever, doesn't matter. I can do the rest of those off camera. All right, so we've got that loaded. I think the only thing I might need to do is actually pull Oh, we don't actually load the texture here. It probably should be, though. I think we pass the Atlas texture in from the standard UI system, which I suppose is fine for it to own that. So I guess I could go here, and instead of having this here, we just pass it in as part of the render data. Yeah, I guess that makes sense. Okay. So I think that's all we need to do for that. Now it's just the execution, right? So I guess what we'll need to do is pass all this stuff. Render frame. We'll just go to the end of this guy. Let's see. So we've already copy pasted all of this over. So now I think it's just a matter of actually trying to get all this stuff to fit, right? To fit in. So instead of self name, that's going to be SUI. Color buffer handle is going to be render data. SUI data, color buffer. So render data, SUI data, depth stencil buffer. And then this is going to be renderer state. And then this will be render data, SUI data, VP rect. This is also going to be, I'll keep this for now, but I'm going to put a to do here. Deprecate this. Render data. SUI data.vp. And it's going to be, this is going to be renderer, SUI pass, SUI shader, right? Okay, so essentially the rest of this is just going to be me doing that, which I'm actually out of time tonight, so I'm probably going to wind up doing this off camera, or worst case scenario, if I'm not able to get to it before tomorrow night's stream, I'll get to it then. What's up with the yellow background? It's an NVIM search highlight. You're exactly right. Yeah, I can clear it. Yep. Yeah, when I search for something, yeah, it's just the search text. I just forget to turn it off sometimes. Okay. Let me just catch up with chat really quickly. Would like to know what your most common bugs are. I know C is risky in terms of memory allocation, but I think you use arenas, so maybe you can avoid those. Yeah, I avoid those, but I do run into problems with it sometimes anyways. You know, I just wind up having undefined behavior because of some of it anyways. The most common things I run into are the most common things you run into in any code base. It's like stupid stuff, right? Dingus-oriented programming. Things like, you know, off by ones, you know, index out of bounds of an array, stupid stuff like that, right? None of it's terribly complicated to resolve once you find it, but sometimes finding it can be a pain. At some point, I do want to enhance the memory system to try and catch some of that stuff, but you can only go so far with that But yeah, that's like the most common stuff I run into is stuff like that. What's the best way to catch up with the state of the render engine? That's a good point. I'm actually like way overdue to do kind of a recap of where we're at. So let me think about how I want to do that, because a lot has happened. Obviously, it depends on where you're catching up from, right? A lot has happened, though. A lot of things have changed. A lot of things have been, cleaned up, refactored, swapped around. The last thing that we worked on, we actually deleted 3 times the amount of code that we added. So we're kind of focusing on trimming the fat and making things a little bit neater and leaner for sure. But yeah, let me think about how I want to do that, because it is quite the list of things. Coworker of mine often makes a mistake of copying some code structure but forgetting to change some variable names. So shadowing makes the code incorrect, or he has to assign an ID to an enum. So that makes no sense. Yeah, I mean, I try to avoid doing stuff like that. I always try to write my structures from scratch, to avoid that kind of thing. I try not to copy pasta too much code unless I'm moving something from point A to point B, because copy pasta errors are like really annoying to solve sometimes. Is there a tool to visualize C/C++ code to show information about your programming, like memory allocations, loop depth, other info, useful info? Probably. I mean, memory allocations I kind of track within the program itself. So you're not going to see like a lot of mallocs and things like that because I track all of that out of my own allocator. But I do actually have a report that you can print out in the console for that. As far as like static analysis, I think is what you're really going after. I mean, there are tools out there for it, for sure. I haven't really used any of them on this project, but at some point we probably will. Watch Jonathan Blow's talk in LambdaConf where he showed a visualization of his upcoming game, and it contained a lot of pretty useful information. I'm wondering if C has a tool to do this. It sounds like a static analyzer. I'll have to watch that talk and see, because I haven't. I did see that one pop up. I just haven't had a chance to actually watch it. But yeah, it sounds like a static analyzer is what you're going to want. All right. Let me find out who we are going to raid for tonight. Let's see. See if I can find quickly. Bear with me just a second. Just looking to see who's available to be raided at the moment. I always try to find something that's loosely related, and if I can't, then I will try something else. But I always like to kind of scroll through for a minute and look. I really do need to raid and run tonight, though, so it's going to have to be quick. All right. All right, you know what? I haven't raided him in a while. We're going to raid Jitspo tonight. So it looks like he's currently doing some modeling, but he's making a pretty cool looking retro FPS. He's got some decent mechanics that he's put in there, and he's actually written his own parser for Quake style BSP maps and stuff like that. So we'll go and see what he's up to, and yeah, I'll catch you guys next time. Thank you guys so much for hanging out with me and being here and following along and interacting and all that good stuff. If you guys haven't already, I would really appreciate a follow either on the YouTube side or the Twitch side, or both if you're so inclined. And I will see you guys. I'll see you guys next time. See ya.